Hi guys, welcome to this tutorial. It's Teacher Raya here. So I am now completing part C of the Form 4 Mathematics paper 2020. Question 13, of course. So we're told point A, which is 4, 2, is reflected in the line y plus x equals 0, followed by an anti-clockwise rotation through 90 degrees about the origin. Find the final image of point A. So two things happened to point A. First, it was reflected on this line I have drawn. I will explain that in a minute. The other thing, it was rotated about the origin at 90 degrees anti-clockwise. So let's just do this line first. What does this line mean? Y plus x equal to 0. Well, this is the line y equals to negative x, and you know it has a gradient of -1, and the y-intercept is 0. It's not there. So the y-intercept is 0. That means this line is going to go through the origin. If you like, you can produce points, but you don't really need. I just have drawn this to show you what happens. Okay, I always use the unit vectors, I and j vectors. Let's put in point A. Point A is at 4, 2. So 4, 2 is this one here. Okay, so in terms of vector, you could write it like this, 4, 2. Okay, this is point A. Now, what happened to point A? It was reflected on this line. This is the line y plus x is equal to 0, which is y equals minus x. In other words, it's the same line. Right, you need to figure out what is the transformation matrix. We can see this visually, which I will show you, but you can also find the transformation matrix. And this is just one trick. Use the unit vector. So when I say that, I'll put the unit vectors somewhere here. So we got I, which is going to be 1, 0. And then we got the unit vector j, which is 0, 1. And we're going to use these two vectors to find the transformation matrix which we need to transform point A. So if I have a unit vector I, that's going to be 1, 0. That's just going to be this vector. Now, if I reflect this vector, so remember this is 1, 0. If I reflect it on this line, so reflection means it's a mirror line. This I vector is going to be right here. What is this point? This point is 0 minus 1. So that I vector has now been transformed to this one. So I'm going to use that transformation vector as my first part. So the I part comes first. So 0, -1. Now I need to know the other part of my transformation matrix. Right. So the other part we're going to use is the j part, 0, 1. So 0, 1 is going to be this one. Okay, so this one is 0, 1. This is my j unit vector. Now, if I'm going to reflect it on this line, this vector is going to be right here. What is this point? This point is going to be -1 and 0. So this j vector has been now transformed from 0 to 1 to -1, 0. And that is what I'm going to put over here. So now I have my transformation matrix. I can use this to transform point A. So point A is 4, 2. Write it as vectors. Now, what happens if you multiply this? You're going to get 0 times 4, which is 0. And then we're going to add -1 times 2, which is -2. So this point is going to be at -2. The other point, -1 times 4 is -4, plus 0 times 2 is 0. So that's going to be -4. So point A has now been transformed. Okay, so this image of A, the first one, that's going to be equal to -2, -4. Right, now we can actually see this visually. I'm going to show you. If we draw in the lines, we're going 4 this way, because that's the point 4. And it should be 2 that way. Now, if this is our mirror line, if that's 4 that way, then we are going to go 4 this way, and then that went up 2, and we're going to go 2 this way. We're going to end up here. You can see the coordinates for this one is -2, -4 is what we have right here. So this vector here will be -2 and -4. In terms of coordinate, that's going to be -2, -4. Now, what happened to this point now, this image? This image has now been rotated through 90 degrees about the origin, anti-clockwise. Guess what trick I'm going to use, guys? Right, guys, so now my image, the first image of A, that's going to be equal to -2, -4. And now this point is going to be transformed by rotating at 90 degrees anti-clockwise. I'm going to use my unit vectors again, I and j. So let's say I have my unit vector here. Okay, so remember my scale was 1, 2, 3, 4, and here that was 1, 2, 3, and 4. We don't really need them. I'm just showing you this is x, this is y. The I vector, that's 1, 0, guys. If I rotate this 90 degrees anti-clockwise, where will it be? I'm going that way 90 degrees. It will be here. What's that point? That point is 0, 1. That makes my first point of my transformation matrix. So that's going to be 0, 1, because I'm going 90 degrees anti-clockwise. Right, now I have my j vector. Let me draw that in on top of this one. That's the j vector. What is it? It is 0, 1. If I move this anti-clockwise 90 degrees, where will it end? It will end right here. Okay, that's my j vector. What's that point? This point is -1, 0, guys. So that makes the next point of my transformation matrix. That's going to be -1 and 0 here. Now I can use my new transformed a vector or coordinate, and I'll put it in terms of vectors. -2, -4. Okay, so let's do the matrix part then. 0 times -2 is just 0. -1 times -4 is what? Is just 4. Okay, 1 times -2 is -2, plus the 0 times -4 is just 0. So you're going to end up with -2. Right, that's your new point. So the image of A after A, let's put it that one, A after the rotation, okay, wow, rotation, reflection, and rotation is, you write it in your own words, is going to be 4, -2. All right, guys, that was this for this question. I hope you enjoyed it. Remember to like, guys, and bye for now.